set this up where we're indexed at the right place. Okay, so we're not going to do that. We can go ahead and unclamp it because we can say we're in rapid. We'll say Z 0.1 and H 180, which is going to move the cutter back out here and then flip the part around so that the pocket, this pocket, is facing us up. So we can simply go in there, Control Save, and just wrap it down. I'm going to say we've got a center cutting end mill. Check for questions here. Nope.
No questions.
Got a center cutting end mill. And so we're going to move to a shallow end over here and just maybe right in the middle and just plunge right in, and we'll work our way out, if that makes sense. Or, better yet, let's start at like this point because it'll be more shallow. Then we'll feed over to here. And then for climb cutting, we'll go to here, 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 here. And then we'll come in here and then finish the rest of the pocket. So we need to know what this point is. So analyze entity. So remember, this is X and this is Y in this world. I guess I could have spun it around and left it in lathe mode. That would be too easy. That would be too easy. So we're really going to be, we're still on center though. Or no, we're not on center. So I'm going to have to actually move this thing to center so that we know where the actual geometry is, because this is telling us where it is from this hole. And that's going to be kind of a pain to do. So let's see if I can do something different here. We'll edit. I'm going to pull this right to the front. And that's going to be a lot easier. We don't really care that it's on the edge of that chamfer. We care more that it's giving us the right X and Y moves.
Yeah.
Alright, so now when I analyze this, it'll tell us where we are from Z, which is actually, our X is going to be Z, and our Y will be Y. Why?
Why not?
So our first point is Z minus 1.188 and Y minus 0.259. And then we'll say Z minus, what was it?
I don't know. I don't remember.
1.188. 5. We'll just say 1.188. And then Y minus 0.250, Y plus 0.259, because we're on this side of it actually.
2 point what?
You know what? I need to rotate that around because we're looking at it backwards. Rotate everything. Sorry about this. 180 degrees. And move. Okay, now
180.
Now that's going to give us our more accurate numbers. Clear colors. So if we don't quite get this pocket done today, we'll save it, and I'll save this and we'll revisit it first thing, but we'll get as far as technical will allow us. We got started a little bit late, but that's on me, not you. All right. Now we want to reanalyze the point. Nope. Okay. That changes everything. Y, see, x minus, z minus 1.066, y minus 0.181. So this puts it in perspective correctly.
What were those numbers?
X minus 1.067.
1.067.
And y minus 0.181.
0.181?
181.
And no z?
Z minus 1.0. It's x is z.
Oh.
Z minus 1.067. Y minus 0.181. Like that. Yes. So that puts us right here. So we're going to feed into the part, and then we're just going to feed up to this point. I could probably just split this screen. It'd be easier. That way we don't have to keep going back and forth. All right, but we don't know what z is. Dang it. Our z is 850 times 2. So 0.850 times 2 is z minus 1.7, or x, actually. So you can see why this gets confusing. X 1.7. We've got this spun 180 degrees, and we're feeding into this pocket in x at 1.7, z minus 1.067, and y minus 0.181 off center, which also translates to this point right here. All right, save all this hard work. Let's see, does anybody have any questions or comments?
No. Well, Ethan said 1.7.
Everybody awake? All right, this needs to actually be a G1. And do we ever give it a feed rate up here even? No. F, let's just go 5 inches a minute, or 4.6. And so it'll pick up that same F4.6 right here. Okay, so now all we need to do is scroll on up to this point, which is z minus 1.188, y 0.260. It doesn't really matter. These tenths don't really matter because we're in the middle of the pocket here. Okie doke. Y 0.260. Now notice we're not using any cutter compensation or anything on this. You can use cutter radius compensation, but I don't want to muddy the water by using cutter radius compensation at this point. What I found programming the Akuma as far as the live tooling, it really prefers that even if you're using cutter comps, that you program the tool path, not the exact geometry. As far as outputting Mastercam codes, I talked about this a little bit at the beginning of the last class and how Mastercam works with this. So if you want to go back and watch the beginning of that last video, I kind of go into that because just did a big honking project where I used Mastercam to program just about every conceivable live tooling thing you can imagine, including a flow tool path, which was pretty exciting to watch that happen on a live tooling lathe. So, okay, so our next point is going to be, so you want a climb cut. So we're going to go probably here next, right? No, that's conventional milling. This way. We're going to feed over to Z minus 1.349. Or 1.345. And Y 0.266. Another thing about using cutter comp in this pocket, you'd have to be super careful about it because it's going to compensate to one way or another. So I think if we were using G41 in here, which is compensation left, since the tool is turning this way, we are climbing. Yeah, it's counterclockwise in the pocket. All right, then we're just going to feed down to here. So I'm just blasting around using my analyze point properties to give us our points here. Z, also X is our Z. Z minus 1.175. We'll go ahead and finish this pocket up, and then we can start fresh with something next week. Y minus 0.181. And then we're going to feed on out to here. Z minus 0.959. Y minus 0.1, and it's still at Y minus 0.181, so we don't have to tell it that. And so we started here, fed up to here, so now we need to go to this point, right? Is everybody following with me? Sort of. What I'll probably have you guys do on this, as far as filling in the blank, is take the tool home and turn the y-axis off and everything. What was I at? Z minus 1.032 and y 0.252 or 253. All right. So now we're going to take our final pass, and so I'm just going to go straight to this point.
Shouldn't it be going the other way?
Huh?
Shouldn't we have gone to the left first instead of the right?
Well, we started here in the middle.
Right.
We went over to here. Then we went down here.
Oh.
And over here.
Oh, okay. I thought you
at this point
went up the middle and then went to the right.
Yeah, now I'm just going to come straight in to here and just mill the rest of it. So we can actually use our drawing for that. Hey, that wasn't so painful.
No.
Find the drawing. All right, so now we'll just say Z minus 0.883, Y 0.422. Y 0.422. And then, of course, I'm pretty sure that this has another Y dimension just to be nasty. Let's save my work here. Y 0.452. I guess we'll go Z first. Y should really technically be first, but it doesn't matter. Z minus 1.603. Y 0.452. And then we'll come down to Z minus 1.295. And a different Y move as well. Now we're going to be going to the Y minus. These two are on the same plane, thankfully. Y minus 0.356. And we're going to come down to U minus 0.752. Notice X is not moving here because X is the floor of the pocket.
Right.
So last move, Z minus 0.883 and X or Y 422. All right, so your job for homework will be to take the tool home and reset it. Because we're done. No, we're not. We're not done yet because we still have to do this feature. I think we'll pick that up next week. And what we'll do is we'll finish this part. So try to fill in all the blanks for this week, fill in all the blanks for this program, and email it to me at, I'll go ahead and type my email in here. Well, it's addison.martinjr@mcckc.edu. I'll type it in. The syllabus too. So if you forget it, you can easily go into your syllabus here. And it'll make you download it, which could be a problem if you don't have Word. Yeah, I never thought about that. Or, I can always text it.
Can you export to AutoCAD DXF files?
What?
Can you export to AutoCAD DXF files from Dave?
You're asking me if I can?
I guess so.
Can I export what to AutoCAD DXF files?
From Mastercam.
Oh, you can. I was doing that. I was going to export to step files last week, and the way you do that is, it was weird because I had to go to File. I had to isolate the file that I wanted to do in another folder. And shoot. Let's go full screen here. You go to File. Oh, escape. File. And you go to Convert. And you have to isolate the file into a separate folder because it wants to. It's gonna blast me. It wants to change everything in that file into a step file. In other words, the short answer to that is yes. And there's some tips on the internet on Google how to do it. Did you want me to export this YC thing to DXF? Is that what you're asking? I can try that after class, but no promises. So that's pretty much what we're going to get done. Let me go full screen here. And I'm going to go into our folder and upload the weekly homework. Save this. And then show you how to access it. And then we'll be done. So build content, file. And we'll call this Y T question mark homework. And then I'll browse my computer. It should be in my, nope. So I'll have to go in. And advanced lathe. Select. And it should blast it in there. So you can go in there, click on the weekly homework. By the way, the YouTube lectures button is right here. And the easiest way to pop in is click on that and then click on this bell. And then you can, it'll blast you in that way. So as far as getting the homework, open up advanced lathe operations, go down to weekly homework, and it should download it for you. You can open it up here and you can like copy and paste it and paste it into another text file or another notepad file or whatever, and then you can go in and edit it and resubmit it and email it back to me. Is everybody good with that? Any questions? Yes, we're good. All right, I'll see if I can't export that drawing into DXF so that you can have a kind of a copy of what we did with X and Y and Z there. If not, yeah, I'm not totally sure I can do that, but I'll try it. All right, I'm going to sign off here. We will see you guys next week at 8 o'clock, and hopefully you guys have a good rest of the day, and we'll see you next week. Ciao.
Yep, you too.